Hello everyone, my name is Rohit Singhal and we were discussing about topic hydrocarbons. In the previous classes we have started with the alkynes, we have discussed about the physical properties of it, we have discussed about the synthetic procedures, preparation methods of it, we were discussing about the chemical properties. Few chemical properties we have discussed and we will continue from there onwards. So, we were discussing chemical properties of alkyne. Okay. So, what we have studied till now, acidic nature we have studied, addition reactions we are studying, right. In addition reaction we have studied the addition of hydrogen, we have studied the addition of halogens, we have studied the addition of water. Now, we will do the addition of hydrogen halides, that means hydrohalogenation reaction, similar as we have discussed for the alkenes. The reactions parallelly go for the alkenes and alkynes. Okay. So, what will happen? This will become a single bond here. Okay. Addition of hydrogen halide, sorry. Okay. So, what I am that means we have discussed this hydrogen halide reactions in the case of alkenes also, similar like this also. The addition of first HBr on one carbon, hydrogen will go, on another carbon bromine will go, and then further reaction with HBr it will give this. Further the double bond will also be cleaved to give the one to the bromide one and one to the hydrogen ones. Okay. So, okay, now you must be wondering also that which carbon hydrogen will go, which carbon bromine will go. It all depends on the that we have discussed previously, the carbocation formation. Okay. On which carbon hydrogen will go, on which carbon the bromine will go will depend on stability of carbocation form. This we have discussed as in alkenes. Okay. So, let us take an example of an unsymmetrical alkyne, then I think we will better be understanding this. Okay. Two paths are possible, right. First part, bromine will go here and it will form a negative charge here. Okay. And the another one is that a bromine will go on to that carbon and a negative charge, it will be a positive charge, sorry, a carbocation forming this one. Okay. So, now these are the two cases that on which the carbocation is going to be formed. As we have discussed in the previous one also, it depends upon the number of about the inductive effect, ki whichever the carbocation stability we can check by the inductive effect or something like that. So, if we see in this case, this is an inductive effect applicable. Okay. That means, this is more stable. That means, this will be taken and a bromide, I am adding the hydrogen here, okay, sorry for this, a hydrogen will go there and hydrogen will go there, and then the bromide will attack, and this will be more stable. So, the bromide will go over there. Similarly, the addition of another HBr, again a carbocation will be forming. You will be seeing that which carbocation is more stable, and with whichever carbocation is more stable, that carbocation will be taken forward and the bromide will react and will give us the final product. So, you just have to see which carbocation is more stable. Carbocation is the intermediate in all this kind of reaction. I have already discussed in the previous lecture also, this kind of reaction they forms a vinyl carbocation something. You see, you have to see the stability of it. Whichever carbocation is more stable, take that molecule forward, react it with the bromide or with the H minus or with the OH minus, react with it, form a molecule, again reacting it with another molecule of water or HX or H2. So, it is that simple, that you have to see the stabilities. Moving on to the next reactions, that is, we can say polymerization reaction. Polymerization reaction. Okay. So, polymerization reactions are also possible, that we have discussed, like in alkenes, polymerization reactions are possible in alkynes also. So, what are these polymerization? There are two kind of polymerizations possible. First is linear polymerization. Okay. For example, let us take an example of ethine if we if this will be polymerized under suitable conditions. So, what will happen? Polyethene we can form, that means okay, this kind of unit will be repeated again and again, and this will be polyethine. Similarly, if I will take okay, this will be this will be like this, like CH double bond CH, CH double bond CH, something like this it will be, okay, connecting again CH double bond CH. So, it will continue growing over both the sides. So, this means a linear chain is forming. What happens is a linear chain is forming, okay, and that is why it is known as linear polymerization. Okay, a linear chain is forming. Okay, what happens? Why these? How this polyethylene polymer? This polyethylene polymer under specific conditions. Under specific conditions, what is the role of this? These do conduct electricity. These conduct electricity, okay, and if and can be used we can use them as electrodes in batteries. Okay. So, what the use of this polyethylene or polyacetylene is, that under specific condition, under special conditions, they can conduct electricity and they can be used as the electrodes in batteries, and they will be a cheaper alternative to the other ones. Okay. So, this is a linear polymerization because it is forming a linear chain. The another one is, the second one is cyclic polymerization. Okay. Cyclic polymerization is what? That means a cycle will be formed. How a cycle is going to form? Okay, this is the ethane gas, ethane is a gas, and passing on this okay. So, what happens is, if this ethane gas or acetylene gas is passed over the red hot iron tube at a very high temperature of around 873 Kelvin temperature, it will undergo a cyclic polymerization. So, what will happen as cyclic polymerization is, this is like this, like okay. Another molecule we can say is like this, okay. Another molecule like say is like this, okay. So, these three molecules arrange themselves like this, okay. So, what happens now? What this will be forming, that there is a C double bond C H H, one bond here C H double bond C H, single bond C H, double bond C H, a single bond here, okay. So, if you carefully see this key, that what this is forming, this is nothing but the benzene, okay. This is benzene, that is represented like this. You have seen that there are alternative pi single bond is alternate pi and sigma bonds, okay. And this can be represented this has one of its form. Now, earlier we have represented like this can also be shown as like this, and in total this is shown like this, that this is the structure, this is the best possible structure to represent a benzene, okay. These two are the forms, these two are the canonical forms of benzene. These two forms of benzene, where a double bond can be shown in different ways of alternating pi sigma bonds, these are called the canonical forms of benzene, and this is called the resonating form of benzene. Resonate bond, resonance form of what this circle represents in between. The circle means that this indicates that the pi electron density is delocalized in the entire ring. So, what is this, like what this circle indicates in the resonant form is that the pi electron density, which I have shown by the double bond, these pi bonds, these are resonating over the entire ring, and this entire ring conjugation can be shown by a circle in the ring, okay. So, this is benzene, there are and this is an aromatic compound, and this is a specific or a special class of hydrocarbons called as aromatic compounds, okay. What the aromatic compounds are, if you remember, I have discussed a bit about them. We will further discuss about in detail. There are few other, okay. Let us represent it by the circle only, better. This is benzene. A few other aromatic compounds are this is naphthalene, that means in the completely the double bond is resonating. Anthracene, phenanthrene. So these kind of these all are aromatic compounds. These all are aromatic compounds. Okay. In all the molecules there are alternate sigma pi bonds. In all those cases, the ring conjugation takes place in the entire ring. So what else these aromatic compounds are, how we can synthesize them, now we will discuss about in detail about the aromatic compounds. Okay. So starting with aromatic compounds. Aromatic compounds. Okay. Start with the nomenclature. We will start. We will discuss a bit about nomenclature and further we will discuss about in the later classes. So, okay. This is benzene. Now say कि one position is substituted. One position is substituted. Substituted means you remember removing the hydrogen by some other molecule. So let's say a CH3 is put over, one of the hydrogen is replaced by a CH3 molecule. So what we will call as similarly what we have done earlier, that what we have substituted, methyl we have substituted. So what will be the name? Methyl benzene. This is also commonly known as toluene. Okay. This methyl benzene is commonly known as toluene. Okay. Similarly, if I am saying this CH2 CH3, that means ethyl benzene. Okay. Similarly, like CH2 CH2 CH3, this will be propyl benzene. Okay. Now let us say two positions are substituted. Two positions are substituted. What I am saying is, let us say one CH3 is here, one CH3 is here. Okay. Now what we will call it? So now we will name the, now we will do the naming or numbering of it. So let us start it from here 1, 2, 3, 4, 5, 6. Okay. We can start from here also. Don't start it here because we start from that position where the substituents are closer. Don't do this 1, 2, 3, 4, 5, 6. If we starting with the 1 here, then start with the 2 here. So 1, 2, 3, 4, 5, 6. So do the numbering which I have told earlier, in the sense that the numbering, the substituents come closer to it. So what will be? There are two methyl positions. Okay. So it means 1, 2, dimethyl benzene. Okay. This is also called as, in common known as orthoxylene. Now what this ortho is ortho. This ortho is written in italic. Okay. This is known as ortho. Write in, this is written in italic, it will be written. Okay. This is orthoxylene common in Indes. Now what this ortho indicates, and what if the position, what if the hydrogen will the methyl will come at the 3, 4, 5, what if the 3 position substitute 4, 5, and what if the all the position will be substituted, what will the name, how will we do the naming, what will be the physical properties, chemical properties of these aromatic hydrocarbons, that we will discuss in the later classes. Thank you.